Today, we are going to discuss limit theorems in evaluating limits of a function, part 4. But before anything else, do not forget to like, share, subscribe, and hit the notification bell so that you will be notified for my upcoming videos. Today, we are going to discuss limit theorems or limit laws in limits of a function, part 4. The first theorem is what we call limit of the identity function. Suppose that c is a real number and that the limit of f of x as x approaches to c exists. And we are going to denote it in the limit of x as x approaches to c is equal to c. Limit theorem number 1 shows that when f of x describes by a single variable x, and we are supposed to find the limit of the function as x approaches to c, then we can say the limit of the function is equal to c. For example, limit of x as x approaches to -2, the limit is -2. Example number 2, we have the limit of x as x approaches to 0, the limit is equal to 0. Example number 3, we have the limit of t as t approaches to 4, the limit is equal to 4. Example number 4, we have the limit of x as x approaches to 10, the limit is equal to 10. And last example, we have the limit of h as h approaches to 8, the limit is equal to 8. Limit theorem number 2 is what we call constant rule. Suppose that c is a real number and the limit of f of x as x approaches to c exists, and it is denoted by the limit of k as x approaches to c is equal to k. In this theorem shows that when f of x is denoted by constant k, and we are supposed to find the limit of the function as x approaches to c, it shows that no matter what the value of the x as x approaches to a certain value of c, then the limit is the constant itself, k. Example number 1, we have the limit of 5 as x approaches to 3 is equal to 5. Example number 2, we have the limit of 10 as t approaches to -3 is equal to 10. Example number 3, we have the limit of -2 as h approaches to 3 is equal to -2. Number 4, example number 4, we have the limit of 4 as x approaches to 5 is equal to 4. And last example, we have the limit of 0 as x approaches to 10 is equal to 0. Limit theorem number 3 is what we call the sum rule. Suppose that c is a real number and that the limit of f of x as x approaches to c and the limit of g of x as x approaches to c both exist, and it is denoted by the limit of the quantity f of x plus g of x as x approaches to c is equal to the limit of f of x as x approaches to c plus the limit of g of x as x approaches to c. Let us have an example. The limit of the quantity x plus 8 as x approaches to 1. We are going to use first the limit theorem number 3, which is the sum rule. We are going to apply the limit to the first term and the second term of the function, so it becomes the limit of x as x approaches to 1 plus the limit of 8 as x approaches to 1. So by this, we can say that we are going to use the limit of the identity function in the first term, and we are going to use now the limit of the constant rule in the second term. So the first term is the limit of x as x approaches to 1 is equal to 1 plus the limit of 8 as x approaches to 1 is equal to 8. Then we can say that the limit of the quantity x plus 8 as x approaches to 1 is equal to 9. Okay, so let us have an example number 2. Suppose that we are going to evaluate now the quantity of negative 2 plus x as x approaches to 2. So let us use now the limit theorem number 3, which is the sum rule. So we are going to rewrite this one using the limit theorem number 3. We have the limit of negative 2 as x approaches to 2 plus the limit of x as x approaches to 2. So by this example, we are going to use again the limit theorem number 1, which is the limit of the identity function, and limit theorem number 2, which is now the limit of the constant. So in the first term, we are going to use now the limit of the constant. The limit of negative 2 as x approaches to 2 is equal to negative 2 plus, in the second term, we are going to use now the limit theorem number 1, which is now the limit of the identity function. So the limit of x as x approaches to 2 is equal to 2. So as we are going to simplify now, we can say that the limit of the quantity negative 2 plus x as x approaches to 2 is equal to 0. The next theorem is what we call the difference rule. Suppose that c is a real number and that the limit of f of x as x approaches to c and the limit of the g of x as x approaches to c both exist, and it is denoted by the limit of the quantity f of x minus g of x as x approaches to c is equal to the limit of f of x as x approaches to c minus the limit of g of x as x approaches to c. Example number 1, we have evaluate the limit of the quantity of square root of 5 minus x as x approaches to 1. So to evaluate now, we're going to use now the limit theorem number 4, which is the difference rule, because in the expression of the function, the operation is subtraction. So applying now the limit theorem number 4, we have the limit of the square root of 5 as x approaches to 1 minus the limit of x as x approaches to 1. So by this, we are going to use the constant rule and the identity function rule to evaluate the limit in each term. So we can say the limit of the square root of 5 as x approaches to 1 is equal to 5 using the constant rule theorem minus the limit of x as x approaches to 1 using the limit of the identity function, that is equal to 1. Then we can say that the limit of the quantity square root of 5 minus x as x approaches to 1 is equal to the square root of 5 minus 1, or approximately 1.2361. Okay, so this is now the limit of the function in example number 1. Example number 2, we are going to evaluate now the limit of x minus 6 as x approaches to negative 8. So applying now the limit theorem number 4. So we have the limit of x as x approaches to negative 8 minus the limit of 6 as x approaches to negative 8. To evaluate now this one, the first term, we are going to use now the limit theorem of the identity function. So it becomes the limit of x as x approaches to negative 8 becomes negative 8 minus, then in the second term, limit of 6 as x approaches to negative 8, we are going to use now the constant theorem. So that is equal to 6. So as we are going to evaluate now, we can say that the limit of x minus 6 as x approaches to negative 8 is equal to negative 14. Limit theorem number 5, which is product of a constant and a function. Suppose that c is a real number and that the limit of f of x as x approaches to c exists, then the limit of the quantity k times the function f of x as x approaches to c is equal to k times the limit of the function f of x as x approaches to c. As what you have noticed in this theorem, the function defined by the product of constant k and the function. To evaluate now the limit of this function, we will just apply now the limit to the f of x and multiply it to the constant k. Let us have an example. So number 1, evaluate the limit of negative 3x as x approaches to 4. So in this example, our constant is negative 3 and our f of x is the x. So to evaluate now the limit of the function, so let us have copy the negative 3 and multiply it to the limit of x as x approaches to 4. So when we are going to evaluate now the limit of x as x approaches to 4, we're going to apply now the theorem of the identity function. So as we are going to evaluate now, so it becomes negative 3 times 4. Then we can say that the limit of negative 3x as x approaches to 4 is equal to negative 12. So let us have another example. We have evaluate the limit of 5 times the quantity of x minus 3 as x approaches to 1. So to evaluate now the limit, so our constant is 5 and our function is the x minus 3. So to evaluate now the limit of the function, we have 5 times, then apply the limit to the function x minus 3 as x approaches to 1. So when we're going to rewrite that one, that becomes 5 times the limit of x minus the limit of 3 becomes as x approaches to 1 x approaches to 1. So we can say that becomes 5 times limit of x as x approaches to 1 is equal to 1 minus the limit of 3 as x approaches to 1 is equal to 3. Then simplifying further, we have 5 times negative 2. Then we can say that the limit of the quantity 5 times x minus 3 as x approaches to 1 is equal to negative 10. Limit theorem number 6 is the product rule. Suppose that c is a real number and the limit of f of x as x approaches to c and the limit of g of x as x approaches to c both exist. Then, the limit of the quantity of the two sub-functions f of x times the g of x as x approaches to c is equal to the limit of f of x as x approaches to c times the limit of g of x as x approaches to c. So, in this theorem, as what you have noticed, the function defined by the two sub-function that was being multiplied, which are the f of x and the g of x. So to evaluate now the limit, apply first the limit of the function to f of x and multiply to the limit of the g of x. Let us have an example number 1. Evaluate the limit of 2x times 4 minus x as x approaches to negative 2. So in this example, our f of x is the 2x and our g of x is the expression 4 minus x. So as we are going to apply the theorem number 6, so let us have the limit of 2x as x approaches to negative 2 times the limit of 4 minus x as x approaches to negative 2. So to rewrite this one, we have limit of 2x as x approaches to negative 2 times, then apply the limit to the expression 4 minus x, that becomes the limit of 4 as x approaches to negative 2 minus the limit of x as x approaches to negative 2. So as we are going to simplify further, we have, so this is a constant and a function, so let us write this as 2 times the limit of x as x approaches to negative 2 times the limit of 4 as x approaches to negative 2 minus the limit of x as x approaches to negative 2. That becomes 2 times negative 2. So as we are going to evaluate now this one, that becomes negative 2 times, okay, so let us now evaluate this one again, this one. So when we're going to evaluate that one, that becomes 4. Okay, as we are going to evaluate now the limit of x as x approaches to negative 2, that becomes negative 2. Okay, so simplifying further, we have negative 4 times 6. Then we can say the limit of 2x times 4 minus x as x approaches to negative 2 is equal to negative 24. Another example we have, evaluate the limit of 2x plus 1 times x minus 1 as x approaches to 4. So to evaluate now the limit, we have to use the product rule. So we have the limit of 2x plus 1 as x approaches to 4 times the limit of x minus 1 as x approaches to 4. So to simplify further, we have the limit of x as x approaches to 4 times 2 plus the limit of 1 as x approaches to 4 times the limit of x as x approaches to 4 minus the limit of 1 as x approaches to 4. And to do this, let us now evaluate now the limit. So we are going to copy the 2. Then evaluate now. Evaluate this one. So the limit of x as x approaches to 4 is equal to 4. So times 4 plus the limit of 1 as x approaches to 4 is equal to 1. And then times, let us now evaluate this one. The limit of x as x approaches to 4 is equal to 4. So we have 4 minus, and then the limit of 1 as x approaches to 4 is equal to 1. Multiply 2 times 4, that gives us 8 plus 1 times 4 minus 1. So we have 8 plus 1 give us 9. So that is 9 times 3. Then we can say the limit of 2x plus 1 times x minus 1 as x approaches to 4 is equal to 27. Limit theorem number 7 is what we call quotient rule. Suppose that c is a real number and that the limit of f of x as x approaches to c and the limit of g of x as x approaches to c both exist. Then we are going to denote that the limit of f of x divided by the g of x as x approaches to c is equal to the limit of f of x as x approaches to c divided by the limit of g of x as x approaches to c. And take note that this only could be possible when the limit of g of x as x approaches to c is not equal to 0. Let us have an example. Evaluate the limit of the quantity 2x divided by x plus 10 as x approaches to 3. Applying now the limit theorem number 7, so we can say that the limit of 2x as x approaches to 3 divided by the limit of x plus 10 as x approaches to 3. So in the numerator, we are going to use the the constant and the function theorem. So we're going to rewrite this into 2 times the limit of x as x approaches to 3 divided by, then in denominator we're going to use now the limit theorem of the sum rule. So we have the limit of x as x approaches to 3 plus the limit of 10 as x approaches to 3. So as we are going to simplify further, we have, so if we're going to evaluate now this one, the limit of x as x approaches to 3, that gives us 2 times 3. And in denominator, as we are going to evaluate the limit of x as x approaches to 3, that gives us 3 plus, then evaluate this one, the limit of 10 as x approaches to 3 using the constant rule, so that gives us 10. Then we can say, as we are going to simplify further, we have 2 times 3, that gives us 6, and then 3 plus 10 gives us 13. And we can say the limit of the quantity 2x divided by x plus 10 as x approaches to 3 is equal to 6 over 13. Let us have another example applying limit theorem number 7. Suppose we have limit of the quantity 3x plus 2 divided by x as x approaches to negative 2. So applying now the theorem, so we're going to rewrite this into the limit of 3x plus 2 as x approaches to negative 2 divided by the limit of x as x approaches to negative 2. Then in our numerator, we're going to use the sum rule in the limit theorem. So we have 3 times the limit of x as x approaches to negative 2 plus the limit of 2 as x approaches to negative 2 divided by the limit of x as x approaches to negative 2. So let us now evaluate each of the limits. So as we are going to evaluate the limit of this gives us 3 times the limit of x as x approaches to negative 2 is equal to negative 2. That is 3 times negative 2 plus the limit of 2 as x approaches to negative 2, this one, is equal to 2 divided by it. Then evaluate now the limit of x as x approaches to negative 2, that is negative 2. So simplifying further, we have 3 times negative 2 gives us negative 6 plus 2 whole over negative 2. Then simplify further the numerator, that gives us negative 4 over negative 2. Then we can say negative 4 divided by negative 2 is equal to positive 2. Then we can say that the limit of the quantity 3x plus 2 divided by x as x approaches to negative 2 is equal to 2. Limit theorem number 8 is what we call power rule. Suppose that c is a real number and that the limit of f of x as x approaches to c exists, then the limit of x raised to the power of n as x approaches to c is equal to c raised to the power of n, where n is a positive integer. Example, we have evaluate the limit of x squared as x approaches to -3. Using the limit theorem number 8, or in evaluating the limit of this function as x approaches to -3 is -3 raised to the power of 2. So simplifying further, we have now 9. Then we can say that the limit of x squared as x approaches to -3 is equal to 9. Another example, we have evaluate the limit of 3x cubed as x approaches to -1. In this example, in evaluating this one, we are going to use now the previous theorems. So applying the constant and a function rule, we can say 3 times the limit of x cubed as x approaches to -1 is equal to 3 times. So let us now evaluate the limit of the function x cubed as x approaches to -1. That gives us -1 raised to the power of 3. So as we are going to simplify further, that gives us 3 times -1, which is the limit of 3x cubed as x approaches to -1 is equal to -3. Example number 3, we have evaluate the limit of 3x squared minus x as x approaches to 2. Using the limit theorem difference rule, so we can say, and also the constant and the function rule, we rewrite this into 3 times the limit of x squared as x approaches to 2 minus the limit of x as x approaches to 2. So simplifying further, we have 3 times the limit of x squared as x approaches to 2 is equal to 2x squared minus, then the limit of x as x approaches to 2 is equal to 2. So simplifying further, we have 3 times 4 minus 2, then we have 12 minus 2, then the limit is equal to 10. Limit theorem number 9 is power function rule. Suppose that c is a real number and that the limit of f of x as x approaches to c exists, then the limit of f of x to the power of n as x approaches to c is equal to the limit of f of x as x approaches to c to the power of n, where n is a positive integer. To have a clear picture in this theorem, so let us have an example. So suppose we are going to evaluate the limit of the quantity 3x squared minus 4x plus 2 raised to the power of 2 as x approaches to -2. To find the limit of this, so we can say we are going to use the function rule first and then apply the previous theorems that we have discussed a while ago. Then we have the limit of 3x squared as x approaches to -2 minus the limit of 4x as x approaches to -2 plus the limit of 2 as x approaches to negative 2 to the power of 2. After applying the power function rule, then let us use the previous theorems or laws to simplify now the limits of this function. So we have 3 times the limit of x squared as x approaches to negative 2 minus 4 times the limit of x as x approaches to negative 2 plus the limit of 2 as x approaches to negative 2 raised to the power of 2. Now we have 3 times, so the limit of x squared as x approaches to negative 2, that gives us negative 2 squared minus 4 times the limit of x as x approaches to negative 2, that gives us negative 2 plus, and the limit of 2 as x approaches to negative 2, that gives us 2 to the power of 2. So simplifying further, we have 3 times negative 2 raised to the power of 2, that gives us 3 times 4, then negative 4 times negative 2, that gives us positive 8, so that is plus 8. Then copy the 2 squared, so simplify again, so that becomes 12 plus 8 plus 2 raised to the power of 2. Then the limit of the quantity 3x squared minus 4x plus 2 raised to the power of 2 as x approaches to negative 2 is equal to 22 squared or 484. Limit theorem number 10 is radical rule. Suppose that c is a real number and that the limit of f of x as x approaches to c exists, and the limit of g of x as x approaches to c exists also. Then the limit of nth root of f of x as x approaches to c is equal to the nth root of the limit of f of x as x approaches to c, where n is a positive integer. Example, evaluate the limit of the square root of 2x as x approaches to 8. Using the limit theorem number 10, we have the square root of the limit 2x as x approaches to 8 is equal to, applying the constant and the function rule, that is now 2 times the limit of x as x approaches to 8. We have square root of 2 times 8. Then we have now square root of 16, that gives us 4. Then we can say that the limit of the square root of 2x as x approaches to 8 is equal to 4. The last theorem that we are going to discuss is what we call direct substitution property. Suppose that c is a real number and that the limit of f of x as x approaches to c exists, then the limit of f of x as x approaches to c is equal to f of c. This theorem tells us that in evaluating some of the limits of the functions, we can simply substitute the value of c where the values of x approaches directly to our variables in our function. For example, we have evaluate the limit of 3x squared minus 2x 7 as x approaches to 3. To find the limit or to evaluate the limit of the function as it is approaches to 3 using the direct substitution property, just simply substitute the 3 where the values of x approaches. Then we have that is 3 times 3 squared minus 2 times 3 plus 7. Then simplifying further, we have 3 squared is 9 minus 2 times 3 plus 7. Then simplify again, that gives us 3 times 9 is 27 minus 2 times 3 gives us 6 plus 7. So as we are going to evaluate now, or as we are going to perform the operation, this is equal to 28. Then we can say the limit of 3x squared minus 2x plus 7 as x approaches to 3 is equal to 28.
And that ends our video discussion at this moment. Thank you for watching. But before you will end this video, please do assess your learnings by answering the self-test activity. Thank you.